Hi guys, welcome to the channel Learning Electronic Repair. Last night was quite a night. England got through to the final of the European Cup. And yeah, I mean, I'm not really a football fan, but yeah, that's great. But it's a bit of like bittersweet for me because although I want England to get through to the final, I want them to be playing Spain. Yeah. And the reason for that is if they play in Spain, I mean, I live in the Canary Islands, Spanish Canary Islands. Yeah, lived here for 5 years. If somebody asks me where home is, I said, "This is home to me. This is home." Yeah, but I'm an English citizen. So it's like a funny thing. If England were playing Spain in the final, yeah, I wouldn't really mind so much who won, you know. I mean, yeah, England win, that'd be great. Probably that would be first choice. But if England lost to Spain, I wouldn't be unhappy because Spain's my home, yeah. So that'd be like really, stress free for me. But no, they played in Italy, so there you go. Okay, so anyway, enough waffle about that stuff. Power supplies, yeah. This is one of the ones I looked at on the previous video, how to repair any ATX PSU. And at the end of that video, I looked at 16 different power supplies I have, all which are faulty with different faults, and we just had a quick look to see what was wrong with each, and we give them each a number, yeah. And I asked people to vote for which ones they wanted to see repaired first, and put it in the comments, and I didn't quite get the response I expected, because, like, to be honest, nobody voted. Nobody voted, so I don't know. If you want to see some more ATX PSU repairs, I'll link that video on this one. Just watch the last part, I'll tell you where it starts, and watch the Hall of Shame, yeah, and get some votes in, and I'll fix some more. I'm going to be doing lots of other stuff. I'm still doing the computer repairs and anything that comes into the workshop that I think is worth putting on, yeah, so it's not all power supplies, but still. We have one here, and I'm going to have a go at this one. So this is number 3, and there's no output on this one. So let's actually have a quick look to see what this is really doing. So to test this, we need to connect it to the light bulb, yeah, the current limiter. This will stop anything from going bang. I mean, these have all been tested before, so I know they aren't going to go bang. But it will also give us some idea of what's actually happening with this, yeah. So we can plug this in. The power supply is switched on here, but the power's off at the moment. And this is ready to go. It's set to limit. So if this light bulb doesn't light up, then there's no power going into it. If it lights and goes dim, there's power going. So this will give us some idea of what's happening, yeah. If it lights and goes bright, it might be the PFC. Let's see what it does. So bleep bleep and went off, like it kind of tried to power up and then didn't, yeah. Let's put it to live, see what it does now. Now it didn't power up and it didn't bleep bleep this time, yeah. Let's back onto the limit. Right, now this didn't flash at all now. That tells me that the capacitors in here are fully charged, yeah. This didn't light up again, so unless something has happened in the meantime, which I don't think it has, this will have a lot of charge in the capacitors. So the first thing we need to realise about this, it could be the dangerous condition. There could be a very high voltage charge in the main capacitors. Let's see, I mean, I've left it off for a minute while I'm chatting. Let's just try once more, see if this flashes. If this flashes again, I know the capacitors are discharging. No, nothing. So we need to open it up and have a look, but we need to be careful. We need to be careful to see what's going on here, because there could be some dangerous high voltages in it. Yeah, it's off there. It's off at the wall. In fact, safety, it's unplugged. Yeah, stay safe. So see if we can get this thing open and have a look. That one's off. Go number 2, 3. This one doesn't want to come out easily. Ah, there it is, it's out. It's out and it's fell inside. Yeah, that's not really what we wanted. Okay, let's try and take the top off this quite carefully. Is it going to come off? Is there anything else holding this together? It seems quite... No, it is. It's coming apart. It's coming apart. Just a bit tight, that's all. Yeah, just a tight connection on this one. Between the bottom and the top of the case, a connection. It's a tight fit, yeah. Okay. So, we're off. I'll just disconnect my little analyzer. I don't need this at the moment. Right, first of all, first thing first. This is a different design to a lot of the other ones we've looked at straight away. It only has one capacitor, yeah, one main capacitor, not two. It has PFC. This is the PFC. Yeah, this is your main drive to the main transformer, and I can see there's only one driving transistor because it only has one capacitor. I think that's related to that. There's another transformer here, which I'm guessing is a 5-volt standby. There's a tiny one down here, which will be the drive to the transistor that's driving the main switching circuit. Yeah. Ah, okay. We can't really tell if there's any high voltage in this. I was hoping to be able to get to the bridge rectifier, yeah, to have a look at the back of the bridge rectifier, see if there's any voltage across it. That would tell us if they ain't charging the capacitor. But this one's not going to be easy to do that. So we're going to have to take quite a lot of care with this one, how we get it apart. Okay, I've decided the best thing to do with this, I actually paused the video there, was to leave it for a while. Yes, I've left it for about 10 minutes or so now, which isn't possibly enough time to discharge the main capacitors, but it will certainly take some voltage out of it, yeah. The power supply has kind of like a plastic thingy which goes underneath it, so I think I'll be able to lift the whole thing out by this plastic basically, and then I should be able to get underneath it and have a look to see if there's any voltage inside here. While waiting a little bit longer, this is the low voltage side, this side of this heatsink. Yeah, this is all low voltage, so I know this area is safe anyway. I'm just going to disconnect the fan. So let's find my wire cutters. One moment. I've lost them. 1 second. Oh no, they're in the right place. They're in the little toolbox where they should be. Okay. So we get this off here. I've noticed straight away this is loose here. The whole thing's wobbling. The chances are, if I pull this off, it'll probably take the whole connector off the board. I'll try and hold the bottom part of it down and pull the lead out of it if I can. It's possible that this has a broken connection. Let me just zoom in on it. Yeah, this is the connector to the fan, and look, the pins themselves are loose, yeah. So it's possible this connection is broken, maybe due to vibration, and the fan isn't spinning, so it's overheated. It's also possible somebody's opened this up before and tried to take this off and managed to break the connections. So I think the jury can be out on that one at the moment. Okay, well, we've had another 5 minutes more, so let's zoom back out and let's get this thing opened, yeah. Okay. So just 4 screws holding the main PCB in. I know this side's safe. I'm happy to get my fingers in on this side. This is all the main outputs, yeah. That's plastic things off there. Screwdriver in here. Get this screw out of here that's kind of stuck underneath it. Okay, that's there. Another trick when you're working on stuff that may have high voltage in it, by the way, is only use one hand, yeah. They say keep one hand behind your back was what we were taught back in the 80s, when there could be any high voltages. The worst thing you want if you're going to get a shock is a shock going right through you, one side to the other. That one's out. So that's all the screws out. Now this thing's now free. So it should, with a bit of luck, this whole thing should actually lift out. I think it's just these wires here that kind of keep it in place. Bend them off to one side. Yeah, out it comes. Now then, do we have in here any high voltages? This is the question, isn't it? This is the question, and what we need to do is to get to the main capacitor, which is here, this thing, and we need to check. So there we go, the main capacitor's here. Let's see, this thing's been off what, 10 minutes, something like that. Do we have any charge? Voltage DC, straight across the capacitor. Yeah, about 12 volts. Oh, you can see it. No, 1.2 volts, sorry, not 12 volts. Okay, so it's safe. It's safe now. We need to get it into a position where we can actually work on it. This one's quite easy. I can actually get it out of the case, in one piece with the wire still attached. That's a bit unusual. Maybe I have to unsolder these wires to get, to take it off the switch to do some work on it. So let's see what it's doing. Let's see what's happening with it. I mean, I suspect that the 5-volt standby isn't running. So if a 5-volt standby isn't running, then the main power supply can't be running, and if that's not running, it's not discharging the main capacitor. Let's see if that's the case. So the first thing we can do, plug it in. It's switched off at the mains at the moment. It's on here, but it's still off at the mains. This is still on limit. This is the voltage across the main capacitor. 1 volt. Let's switch it on and see what we get. 318. Now let's switch it off. Can you see it? This is off. This is off. This is what I say about dangerous voltages in power supplies, even when they're not plugged in anymore. Okay. What's the best way to get rid of that? Well, it's not stick a screwdriver across the terminals, like make a big flash and a bang. It'll discharge it all right, but it's not really the way to go around discharging these. The best way to do this is to use a resistor. You can wait, obviously you can wait, or we can use a resistor. See if we find something suitable in my box full of power resistors. What I'm looking for is something that's maybe about 4.7 kilo ohms or something like that. What is this one? 3.3 kilo ohm resistor. That 3K3. Can you see it? Zoom it down a little bit for you. Okay, I've just zoomed it in a little bit. Can you see the voltmeter? Let's see what's in this capacitor. I mean, this has been off for a few minutes now. This has been off for a few minutes. What have we got on here? 208. Still too much. The way to do this is to use a resistor, pair of pliers, get hold of the resistor, and literally just connect the resistor across the capacitor. That's just 3.3k, so nothing should much happen. I'm just going to hold this against the capacitor, for a few seconds. Okay. Now let's see what voltage we've got. 2. Safe with your fingers now. I mean, it was safe-ish with it was safe with your fingers before, but let's take precautions. 0.6 volts. So this is discharged. Okay. 0.4. I suspect the 5-volt standby isn't running. the 5 volt standby isn't running, nothing else can run, yeah. So let's have a look. Let's try it. Okay, let's see if we got any 5 volt standby. So any of the black wires, yeah, and we go to the purple wire, yeah, that's 5 volt standby. Okay, let's see what we've got. I'll just hold them in here easy. Well, you see a bit of voltage there, so maybe it has got 5 volt standby, yeah. Light bulb still in circuit, might flick again. Let's in fact it should flash because I've discharged the capacitor, yeah. Yeah. 5 volt standby is there. Okay, so we have 5 volt standby, but we don't have any main power, yeah. No any main power. Notice your 5 volt's still there because your high voltage is still there in that capacitor, yeah. So again, we'll come with the resistor. Once I discharge this, that'll go as well. Taking its time, isn't it? Did I get a contact on this to discharge it? Yeah, I did. We have 5 volt standby, guys, but we don't have any main supply, yeah. Okay, she's safe, yeah, 0.3 of a volt. Unplug it. It was switched off at the isolator. I have an isolator which breaks both wires live and neutral. So, why isn't the main power supply running? Well, a couple of reasons possible for that. First one would be that there's the driver IC isn't driving the switching transistor, yeah. Or the second one is that it is driving the switching transistor, but the switching transistor isn't switching, or there's no current path from live via the transformer through this resistor to ground, yeah. We've also noticed, you can see here, some wires soldered on here, yeah. Couple of wires, so somebody's been in here before. That's on the that's going to this board, and this board, by the loops of it, on the secondary side, has probably got the controller IC on it. That in there is probably the controller chip for the switching transistors. Okay, I think the first thing to check is continuity on the high voltage side. So let's have a look to see how this one actually works. Okay, so as I say, this is quite different from the other ones we've looked at. Having a quick look around it, I can see that the 5 volt standby will be this transformer. I'm sure this will be the standby transformer. Looking down here, I can see an IC. You see 3 legs, there's a gap there, yeah. And if you look down the other side, you might see the other 4 legs here. These chips with 7 pins on are normally drivers that drive a power supply, and the pin where there's a gap, effectively the one other side of the gap is the high voltage pin. That's why they don't have a pin in between to stop any arcing. So that'll be some sort of power supply driver, yeah. I'm suspecting this is probably driving the 5 volt standbys directly. We can have a look at that, and we can also figure out if it's standby. There's a couple of wires here, black, but I think they got like some sort of like rubber sleeving on them, yeah. And we can have a look to see if this wire which disappears under here actually goes to standby, yeah. If that goes to the purple on the ATX connector, then we know this is the 5 volt standby supply, yeah. So let's have a look. So purple wire in here, yeah. And want to have a look, let's get the meter where you can see it, yeah. And I want to know if it goes to the wire coming down here, yeah, which by the transformer. Where's the end of my meter? I'll find the test lead. Yeah, it's here, guys. So 5 volt standby. Is it here? Yeah, that's a good guess now, because that's exactly where it is. We know there's no shorts on it because 5 volt standby is running. So this is 5 volt standby here. This black wire, yeah. That'll go to this transformer. It's right by it. It'll go to a diode down here somewhere. probably this thing I can see here. That's probably a diode, and it's probably connecting to this. Can't tell directly, but I suspect it probably is. It's got 3 legs on it, man, but it'll still be a diode. So if this is the transformer, then this is where we have this chip with 7 pins in it, yeah. This thing here, yeah. And that'll be the high voltage pin, the one that's over there. And I'm wondering now, does that go to this transformer? And I think I can see actually that it does. Yeah, so from the high voltage pin here, which is always the one after the gap. There, this is your transformer. Okay? So that goes to that. So we can say with a good degree of confidence, this is driving the 5-volt standby, yeah? This is the transformer and this is the wire. We know this is the wire. So really we know. That's your standby supply. We know that's working. Now, we have 2 other transistors down here, one this side and one this side. Maybe there are 2 after all. I thought maybe there's only 1. There's a little circuit board in here with a cover on it. I suspect that is the controller for the PFC. This is your PFC on here, yeah? Active PFC, which will have, yeah, looks like a transistor. There's 3 devices on it: transistor and diode, or transistor and 2 diodes maybe. But actually imagine this is the PFC. So these 2 transistors here, which by the way are connected together, yeah they are, in parallel, right, I think they're in parallel. They'll probably be driving this big transformer. So let's have a look. So this is one of the devices, yeah. Well, I can see straight away, this is the transformer. Yeah, where's the other ones here? Oh yeah, this is the transformer. Yeah. So we know we have a device here, 3 legs and 3 legs, yeah, one's there, one's here. And those are driving, those 2 are driving this transformer, yeah? We know that's for certain. May well be a half bridge circuit. Although normally a half bridge has 2 capacitors. There's a little transformer down here. But this transformer, if you see here, this big gap, yeah, down here, this is the gap between the high voltage and the low voltage side, yeah. We have here 2 opto-isolators bridging the gap there, yeah. We have the main transformer bridging the gap. We have the standby transformer bridging the gap, yeah. There's never any connection from the high voltage to this side, only isolated via transformers or opto-isolators, yeah. I've spotted on this one there's actually a 3rd opto-isolator here, but this will be part of the standby circuit, yeah. It's there at the end, 1 there and 2 here, so there's 3. So I'm thinking this is probably the PFC controller, yeah. And I'm thinking that on this board there's probably the main power supply driver, yeah, the IC, the controller that's controlling these 2 transistors, yeah. Now, if that's the case here, again, I think we can pretty well prove it. We know that the green wire from the ATX power supply activates that, yeah. So if we go into the green wire of here, we'd expect to find a connection somewhere to here. Yeah, there. The fact is this here the wire? Yeah, it's the wire. It's the wire, yeah. So we know the green wire goes to this. So we know without a doubt this is the controller IC that drives those transistors, yeah. So what we really need to have a look now is to take this heatsink off, check the transistors, and we should have a path running from live, you know, the output of the PFC, into one of the transistors, through the coil, through the other transistor, and back to the negative. Let's say live, positive and negative output of the bridge rectifier. Yeah. We might be able to see that actually. Here's the bridge. Bridge is on this heatsink. Yeah. So 4 big legs here. 1, 2, 3, 4. This is your bridge. Yeah. Now, I'm expecting to find from this bridge going somewhere to one of these 2 big transistors. Doesn't go there. Goes to that one, yeah. It goes to there, yeah. So this transistor is connecting to one end of the bridge. The other end of the bridge, I'm expecting to be going to the other transistor. No, it doesn't. So where's the other end of this bridge go to? Okay, we need to trace it through. I thought that might go to the other end of one of these transistors. It's possible there's an open circuit there, so that effectively is not connecting into this circuit, yeah? Obviously the two transistors go via the coil. And the coil's good, but there seems to be no return path from here back to this bridge rectifier. So we need to have a look to see how this circuit is, yeah? Well, actually this is one end of the capacitor, the big capacitor, which obviously goes to the bridge as well, somewhere. Yeah, it must do. That end goes to that one. Oh, it'll go via the PFC. The PFC is in between, probably a diode junction. I'll probably say a diode junction. No. Okay, we need to investigate that a little bit. Let's put it into diode mode. Okay. From this end of the bridge rectifier to the capacitor. Yeah, via a diode. That's in the PFC circuit, so that's good. So, main capacitor, negative, positive. Negative should go to one of these, not this. I can see positive goes to this transistor. I can see that straight away. Positive goes to this transistor, the two big ones. So the negative should go to the other one somewhere. Yeah, got it. So, positive end of the big capacitor, yeah, goes to one of the transistors. Looks like the collector, the middle pin, or there might be drain source. Drain, probably, if it's FET. And the other end of the big capacitor goes to the other transistor, yeah. And via the two transistors, they're connected together. Again, that's like the collector or the drain, collector emitter, yeah. So we have a path, we have a circuit path there. Can you see it? Can you see what we have? Bridge rectifier, yeah? Negative to this end of this capacitor, yeah? Positive to the other end of the capacitor via a diode, which is in the PFC. Plus, minus, yeah? Then from your positive, it needs to go through one of the transistors, the big ones, through the coil, through the big transistor to negative. Obviously, only when the transistor's switched on, yeah? Not just like a short, yeah? But we need to have a connection from here to one of the big transistors. And we can see it's this one, yeah? And from the other end of the big capacitor, there needs to be a connection to the other big transistor. Yeah? And then from this side of this big transistor, yeah, via the coil to this one. Yeah? So you can see it. Do you want me to draw it for you? Go on then. Let's just draw it and then you'll know exactly what we're looking at there. One moment. Actually, just before I draw it for you, let me just see if we can tell if these are MOSFETs or bipolar transistors and do they look like they're okay. These are the two main terminals with thick tracks. I'm guessing the other one, it's not guessing, I know the other one will be the base or the gate. Anything from there to there? No. Anything from there to there? No. Just go the other way around. There to there. No, there to there. Right, they don't really like bipolar transistors, that one certainly doesn't. Let's look at the other one. So the main tracks are here and here, so this will be the gate, the one with the small track will be the gate or the base. No, nothing there, nothing there. I'm on diode mode. Right. These are probably FETs. They're either FETs or they're not, or they don't work, yeah? Now let me draw it for you. Okay, let's just zoom out a little bit. Okay, so what we have, we've got AC coming in, yeah, AC 240 volts, going to the bridge rectifier, AC, yeah, coming out the bridge rectifier, plus, minus, yeah, plus, minus, okay. Connecting from here we have the the 5 volt standby. We know that works, so that's okay, that's working. Then we've got a large transistor. I'll draw them like bipolar, but I think they FETs, yeah. A transformer and another one, yeah. And we know that because, oh, and in between, sorry, in between there's a PFC, yeah. And the PFC basically consists of a coil, yeah, a diode, yeah, and then from the junction of here, a MOSFET switching to ground, basically. Say ground, hot ground, yeah, dangerous ground, yeah. So that's what we have, and also the PFC has one other diode like this. Okay. So what I was measuring from one end of the, oh, and I've missed something out, sorry. The big capacitor, yeah. We know this is charging up. We know this has like 300 volts in it, yeah. We know it's got a high voltage, so we know there's power getting to here. I was measuring from here, yeah, to one end of the capacitor, and I can see a diode junction. That's one of these diodes, yeah. The other end, negative, was connecting directly. I could see that, and I could see that. I know that it's there anyway, because I know I've got power to here, yeah. From the main capacitor, I could see a connection to one end of one of the transistors, like the metal. There's 3 pins, yeah. 1, 2, 3, and this will be 1, 2, 3, yeah. And I can see a connection on this one to pin 2, the middle one, yeah, pin 2. I can see a connection from there to the coil, and then from the coil to the other transistor, and then on this one, which is also like this with 3 pins, yeah, 1, 2, 3, I can see a connection from 3 back to there. So I know this circuit is there. This device doesn't read like a transistor, so it's either a FET or it's faulty. That doesn't read like a transistor, so it's either a FET or it's faulty, yeah. If these two test okay, if they're FETs and they test okay, then we can say with good degree of certainty that these base, gate, they'll be gate, whichever base, have got no drive. So nothing ever drives this, yeah. There's no power getting, well, there's power voltage across it, but there's no drive. They have square waves coming in, yeah. Probably one upside down to the other one, out of phase, yeah, and there isn't any. Okay. From here, this is your main secondaries. 12 volts, 5 volts, 3.3 volts, yeah. That's what I was measuring. Can you see it now? Okay. So, how to proceed with this one? Get the wire from underneath the wheel of the chair. That's how to proceed. A wheel of my chair was on one of the wires. Couldn't move it. Right. We take this heatsink off and we have a look to see if there's any problem with these devices. There's 2 devices on here. It looks, by the way, that there, that unsoldered joint, is one of the pins that hold this in place, I think. Looks like somebody's had this off already. This transistor looks like it's probably been soldered already, yeah. I'm suspecting these are probably okay. So we'll get this heatsink out and we'll check to see if they're okay. If they're okay, then we can assume the drive comes from here, because the green wire comes down to here to turn it on and off, yeah. There's also some sort of repair work gone on around here as well, which makes me very much suspect that this isn't working. So we'll need to unsolder this and have a look to see what's on here, yeah, and see what we've got and diagnose this. So it's either going to be that or it's going to be this, I would say. Okay guys, I'll see you very soon and we'll continue with this one. Okay guys, another day, same power supply, yeah. So this is our PSU we were looking at yesterday. I've removed the heatsink with the 2 driving transistors on for the main power supply. and we can see the effects. Yeah, this one seems to have a bit of glue on it. I think that's just glue. I don't think anything worse than that. IRF 18N50, and here's the other one. IRF 18N50. This is a very common N-channel MOSFET, and to be quite honest, this is one you should probably keep in stock. You see this a lot in power supplies, and yeah, they're not expensive. So, are they any good? Let's have a dig around and get my components analyzer. Yeah, let's get the components analyzer. Okay, let's have a look to see if these are good. I suspect they probably are, but we need to be certain. Yeah, I mean, suspecting is often good. Sometimes that's all you've got to go on, but it's nice to prove stuff. Oh, I've touched the two wires together. How not to test MOSFETs? Yeah, by shorting two wires together. Let's have another go. Okay, let's see what it does. Yeah, enhancement mode N-channel MOSFET. Yeah. It's good. It's good. Okay, let's have a look at the other one. It's on the other side of the board. Okay. Yeah, that's good. Yeah. Okay, so we know the output devices are good, yeah. Right. On to the next bit. Let's just zoom back out again. Okay, so I'm going to leave this out just for the moment. We don't need that at the moment. Just out of interest, by the way, down here, I spotted a couple of things. This little transformer I mentioned before, if you look at this on the other side of the board, it actually goes to these 4 pins here, 1, 2, 3, 4, yeah, and I can see that some of these are connecting to the gate of the FET, yeah. There's like a wire link from there to there, and that comes into this bit of circuitry by this coil. I haven't actually measured it, but I believe that is connected to the gate drive in one way or another. Let's have a quick look and see what this thing's doing. And I'm not sure it's a transformer. I mean, there are 4 pins all on one side of it. It doesn't connect directly like that. Let's have a look. Okay, it doesn't connect directly to them, but I do think it's involved in this circuitry with a few components around here. But first of all, I'm not even totally sure it's a transformer. These are 2 little transistors next to it. It might just be 2 inductors. Yeah, let's have a look. See those pins connect effectively together. Yeah, there's 2 windings. It could be a little transformer, or there could be like 2 inductors. But it's obviously in this area, and I'm sure it's involved with driving the gate of the FETs. Now we know the FETs. But as I mentioned on the other video, I'll put on the comment of it, the subtitle if you like, the addendums. I started to talk about it, I forgot what I was talking about. Yeah, I went on about this. This is on the high voltage side. It's not bridging the gap between the two. Yeah. So if it's involved in driving the gates and the controller IC is over here on the low voltage side, the drive must come across a different way. And we've got the main transformer, we know we've got the standby transformer, and this opto isolator here is a feedback for the standby 5 volts. And there's 2 more here, and my supposition, kind of a guess, educated guess, that this must be driving these transistors somehow, and it can't be, and it's got to be isolated from the high to low voltage side. And there's two more optical isolators here, and I'm thinking that's probably what these are. I think one of these drives each transistor, and that gives the isolation. I'm guessing it's not a common design. Well, maybe it is, but I haven't seen this type. Most of the ones have been the other type with the 3 transformers. Okay, so anyway, we've taken them off. Quite evidently now there's no drive. I mean, I'm sure the drive comes from, there's an IC on this board. We can see, can you see down there? Yeah, there's the chip, yeah, with what looks like an electrolytic capacitor stuck on the back of it with a bit of glue. Yeah. Another afterthought by the circuit designer. So we're going to have to take this off and have a look at what this is. The fact we've now got, we know there's bits of wire been tacked on around here, so something's happened around here. I think we might have to have a look at this as well and try and figure out if these are in the right place. The other thing I noticed is down here, can you see it there? Let me zoom in on it properly. Yeah, down in here, there's a bit of wire sticking up in the air, and there's another hole there. And I don't know whether this has come from there and what it does. It looks like try to figure out where this is. It's somewhere in the middle of here. Sorry, somewhere in the middle of here. I don't know whether it's to do with this. This is connecting to one of the main transistors. I probably ought to try and work out what this wire is for, sticking up in the air. It looks like it's been unsoldered. Well, if it was unsoldered, it wouldn't go into that hole there. Yeah, it's not in the right place. The end of it looks slightly bent, but it wouldn't fit in that hole. So at the moment, I don't know what that is. I'm not going to worry about it too much for now. I have seen sometimes like this, wires sticking up, which turn out like it's some sort of option. Yeah. So, because I don't really know what that's for, I'm going to kind of like just not worry too much. I don't think it was soldered to the heatsink itself. I mean, it's definitely somewhere. Yeah, it looks like it might have touched that heatsink, but I can't see. It couldn't have. This is aluminium, so you can't solder to this. Yeah, I don't know. That's a mystery. Okay. So anyway, let's get this. Sorry, I have to zoom out. Let's get this board unsoldered and have a look to see what we have on here. Now there's a lot of pins on this soldering this circuit board, yeah, and the tracks are, you know, they're not dead fine, they're fairly fine, some of them. Normally if it's like an IC and I didn't want it, I'd just cut all the legs off and remove the pins. But obviously I can't do that with this. I need to unsolder this so we can, you know, check it out and put it back on again. So I'm going to use a vacuum desoldering tool on this one. You might get away with solder braid. Oops, that's my soldering iron stand fell over. Okay. But what I'm going to do with this, I'm going to first of all come along and add some leaded solder. Yeah. Interesting with this, although these wires have been soldered here, this to me looks like this has never been desoldered. Which makes me think that why would these tracks have gone? Was there some sort of short somewhere? And was it on this board? Well, then you think if that was the case and you solder thick wires so the track can't blow, something else would go, yeah. Maybe it's that. Okay, so get some solder on there. Just get in with the desoldering tool and just effectively make short work of this, yeah. We're back on level 2, by the way, the COVID restrictions from this morning. Back up to level 2, so that means all the bars and restaurants and they're all shut at midnight. Clubs won't be open because they didn't even open till midnight, yeah. After 2 weeks ago, they removed the requirement to wear masks. So prior to that, we had to wear masks everywhere, indoors or outdoors, unless you're actually eating or drinking. You could lie on the beach without moving around, or you could go in the sea or go cycling and running, but other than that you had to wear masks everywhere. So we're back to midnight closing, but at least we don't have the curfew. Previously we had the curfew where after midnight and before that on level 3 after 10 PM nobody was allowed outside the house apart from emergency. So nobody was on the streets apart from the police hovering around looking for people to fine, yeah. So at least we don't have that again, just the early shutting. Outside is done. The other funny thing, by the way, I've been wearing masks here outdoors for 11 months, yeah, until 2 weeks ago when they removed the requirement. And for like 2 weeks, I've been wandering around and I'll go out and I think, well, I've got my mask on. You know, I'll get the car, well, I've got my mask on. Because you've got to carry it with you, because, you know, obviously indoors anyway, we need to wear them. And it's like, it's taken me 2 weeks to figure, you know, to remember not to wear a bloody mask. It's like, it's nuts. That just shows how accustomed, you know, you don't like the idea, but after 11 months, you're so used to it. You keep thinking, I've got, why am I wearing that? What's that about? Yeah. Anyway, I've unsoldered this little board. It's very simple. So we have one chip, one capacitor glued to the back of it, and 2 diodes. Yeah. So we can fairly easily diagnose what we've got here. So let's zoom down on this and see what it actually is. It's probably a KIA 7500 like that other one, or some equivalent to that. Let's have a look. Okay, so it's a well-trend. I think that's 7525 WT, is it? Let me just get my magnifier. I'll just have a quick look. 1 moment. Yeah, WT7525. So this will be the pulse width modulator controller. So there's nothing much on this board, is there? There's just a capacitor, which I'm guessing is probably connected between the VCC, the power pin, and ground. Yeah, I'm just kind of, it's a big electrolytic, I'm thinking that's where it probably is. I don't know for sure. But we can look at the data sheet of the meter. There's a couple of diodes on here. So we can just have a quick look, just see if the diodes are okay for sure. That's the first thing. So there's a diode. Let's go into diode mode, yeah? There we go, diode mode. So yeah, that looks okay. This one will be this way around. Yeah, so the diodes look okay. Is this? It just reads like a diode in the reverse direction. This is the positive end of the capacitor here, so I'm guessing this probably reads nothing. Okay, so that's all that's on here. Obviously there's a few resistors. I don't see any transistors or anything on here, just some resistors, capacitors. Okay, let's have a look. Okay, so I've found a data sheet for this one. Let's have a look to see what we actually have. Yeah, let's have a quick look and see what we have. So this is the data sheet. It says it's a power supply supervisor. Yeah. Description: over voltage, under voltage detection, monitors the 3.3, 5 and 12 volt A and B input levels, yeah, over current detection on them, power good output, fault protection latch output, output for power good. This is your power supply on button, yeah. Debounce, that means basically when you press a little switch, like you don't instantly go from like no connection to connection. It effectively, you know, the contact can bounce inside it. So this delay is like once you push the button, it waits 38 milliseconds before, you know, determining is the switch pressed or not. That's, you know, effectively, so when you press the button you get one signal, off to on to off, yeah, or 5 going to 0, which would turn this chip on, yeah. But what it doesn't mention, it says this is not a pulse width modulator. Look, there's different versions, yeah, 160 and 161, our chip said 161 on it. Let me print this out, and we'll print that out, and we'll print, yeah, these are pins. Let's print them out, and then we can have a look at ours and see exactly what it is that we've got here. Yeah, we'll do that, I think. Okay, so here's our data sheet. There's 3 different versions of this, 14 pin and there's 2 16 pin, yeah, and I'm not quite sure what the difference is between the two, but ours actually says 161 on it. It says N161 after the WT7525, so ours is this one, yeah. First thing we can see is pin 2 and 15 is where there's little capacitors soldered, positive to 15, and I said that this probably goes from VCC to ground, yeah, if you remember, which it wasn't that long ago, so you probably do remember, yeah. So we know there's no short VCC to ground to actually measured across this capacitor, yeah, and there was no short there. But this chip does not drive the pulse width modulation for the output transistors. Here's a list of all the pins, yeah, and we can see pin 2 is ground. There must be a pin number here, but 1, 2, yeah. Power good, grounds, and so on, yeah. That's 15, power supply, VCC. So all these pins here it mentions, they're all like monitoring, like they're monitoring over voltage, over current and such, yeah. And so I'm pretty much sure, well, in fact I know 100%, this is not driving the main output transistors, yeah. It's just monitoring all the outputs on here. So that begs the question then, is what's driving the main outputs transistors, the main drive for this power supply? And I've had a look around on here, and there's nothing on here to see. I mean, this thing here, that transistor thing, that's a 12 volt regulator. Obviously, it just makes it a bit brighter for you. It'll increase the brightness of it. No, the camera doesn't want to do that. Okay, so this down here is a 12 volt voltage regulator. That's nothing to do with it. There's no other chips under here. These are just the output inductors, the output capacitors. The only other chip I think I can see is on here, and I supposed earlier this was probably the controller for the PFC. But I'm thinking now this is likely to be the controller for the PFC and for the main drive, yeah. So we need to take that off and have a look to see what that is. I can't see any other chips on here. 2 opto-isolates. I'm guessing this is communicating from here, you know, monitoring the voltages to tell this what to do. Also, if you notice on this little board, this chip, this also has the power supply on button on it. PS on, yeah, on off switch input, yeah. And again, I'm pretty much would say that this is signaling via these 2 opto-isolators, whether to switch on and whether to, you know, increase or decrease the power, make sure the voltage stays stable. But before we have a quick look at that, I'm interested to know where these wires have been soldered, yeah. So I'm going to take these off. I'm also going to count the pins, so I can see this goes in here, yeah. This wire, let me see, does this wire actually go to any of the pins on here? What's it doing? It doesn't look like it maybe not even go to here. I think it possibly does. Let's have a close look at this wiring, and if we can figure out if it goes to any of these pins, we can work out on where on this chip it was going to, yeah. And that might give us also some idea. But I don't think there's a short on here. The other thing on here, there's a lot of 0 ohm resistors on here as well, and we'll have a quick look at those and see if anything wrong there. So we'll try and determine as best we can if this is likely to be working. And it's only because of these soldered wires that makes me wonder there might be something wrong with this. Okay, let's zoom that down. Okay, I've put the meter where you can see it. Yeah, we're on diode mode. So let's have a look where this wire is actually going. So it comes from here. Obviously, one end's going to here, and one end's going to here. Sorry, the focus is just gone. So let me just adjust that a little bit. There you go. Question is, does this wire go to any of the pins on this? I'm on diode mode, so you might see the occasional diode. That was a diode junction. That's another diode junction. Oh, capacitor charging. capacitor charging, that looks like. Yeah. Charging. I'm going to switch to resistance mode. It might actually be easier, you know, to just do this on continuity rather than on the diode test. I'm getting too many bleeps that way, yeah. But I don't see a short to this wire. This wire connected anywhere. Nothing. Nothing. Wow. Yeah, nothing. 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 No, it's really like a resistance, that's all. That is a capacitor charging. Nothing. Nothing. Capacitor charging. Nothing. Nothing. Oh. Looks like it goes to this end. That's a low resistance. I have some low resistances. What I've noticed is all the you probably can't see it, but there's like a leg of a component here. It may or may not be touching the next track. I don't think it is. Let's just be sure. Let's get rid of that. I don't think it was. I can hardly see the meter myself, by the way. It's to make it so I can see it a bit better. Yeah. No, now I've blocked what you want to see. The fun with this, I tell you, trying to get everything shot so you can see what I'm doing and I can see what I'm doing. 50 ohms, it's not a short. 50 ohms, it's not a short. It appears to go to there. Yeah. Well, it also appears to go to there. That's ground. I think that's yeah. These are all your grounds. Yeah, these are all your black wires. So this wire is connecting to ground, basically. And it connects all these pads to ground. This looks like a, I don't know. Doesn't connect to it. It looks like a broken wire, but it doesn't connect to it. Whatever it is. That going up underneath that resistor. Does that there go to this here? We'll just dig in a little bit. I don't know. I'm going to just lift this up a little bit. That's what oh. You know, now it comes off the board. What's under here? I'm going to have to take this off, guys. I'm going to have to take this off to see what it is. Yeah, I don't know what this is. I really don't know what this is. Let's just zoom out a little bit and let's just unsolder that. Let's have a look what this thing actually is. Okay, so what we seem to have here, well, obviously we have a piece of wire soldered to the board for some reason. But this end's loose, yeah, it's like wobbling around. I'm not sure why. So we've got this end here. Which goes to a track which kind of goes up that way, yeah. This end here. Yeah. And then a pin which came out the board. Yeah. And I can see, oh, I can see now, this is broken. So, I know what it is. I know exactly what this is. Do you remember when we started off and I said the fan, the thing was wobbling around? Yeah, one of the pins to the fan was wobbling around. We've just found out a wobbly pin. That's what that is. That's exactly what that is. Certainly nothing to do with the, the controller board. Yeah, that's our wobbly pin going up to the cooling fan. Okay, I'll just solder this back on again. One moment. Okay, I've soldered this back on and put a bit of glue on it as well, just to hold it in place so that the pin doesn't wobble. You can see now on the other side of the board that's exactly where it goes to. Yeah, it's the connector for the cooling fan. So that's nothing to do with this. Yeah, so I think we don't need to worry about checking all the resistors and things on here. It doesn't connect to this. Yeah, it's not like something on here drew a lot of power and blew the track. It's just, you know, that wobbly connector on the fan. Okay, so next thing I think we need to have a look at is the other controller, which is over here on the high voltage side, and that's this row of pins here. So I'll get the desoldering tool on and let's remove this and see what we have on this one. Okay, so I'm just waiting for the desoldering tool to warm up, and I thought let's have a quick look at this while we're waiting. So these are your opto isolators here, the output side, the high voltage side, yeah, and this is where the little controller thing is. And if I look at these opto isolators, I think this is ground, yeah, 0 volts. So one end of them is going, probably both of them, yeah, one end's going to ground, yeah. Let's say ground, hot ground, yeah, which is the reference for the high voltage side, not safety ground. The other end, this one seems to come down towards this chip somewhere. No, that doesn't go to it. Let's look at this one. Yeah. So the other end of this opto isolator goes to this board. So that's certainly sending a signal into this. The other one, it looks like it goes this way to a resistor, yeah. And then possibly also goes down here, not sure. No, it doesn't, but it goes to this resistor. So from this resistor goes to another resistor. This is a transistor, or FET, probably the gate or the base. The output of that is probably here. Is this going to ground? No, it doesn't go to ground. So the output of that one is probably just, I'm just interested to see if it comes over to here, yeah. Not obviously, but certainly one of them does, and I suspect the other one gets there as well, one way or another. So let's take this circuit board off and see. I'm pretty sure we're going to find here a combined pulse width modulator controller and PFC controller chip, yeah. Let's have a look and see what it actually is. I wonder if this is a pin on it as well. You see there's a gap. I wonder if it also goes to, and this is a high voltage pin maybe, some sort of drive. Wouldn't be surprised. Let's just clean this. Always when you use this you need to clean it before you put it on one side, because otherwise they have an habit of clogging up, and when they clog up they can be right. In fact, yeah, it was going to clog then, you see, but I've cleaned it. When they clog up they're a pain. Okay, let's see if we can take this little circuit board off here. Is it loose? It's loose. It's loose, but there's another pin here. Maybe this is just like a bracket that holds it in place, these two. Yeah. Although I suspect the connections. Oh, it fell out. Again, once you've done the last solder joint. Clean it. Okay, so we have our controller chip, yeah, on the circuit board. Okay, this was in this way round. What we got? Glue. Another load of little resistors and components on the back of it, and the chip. It's covered in glue, so I'm going to have to try and clean this off with something so we can look at the port and let me have a look to see what we've got. Okay, I've got it. This is a little circuit board. It's under the microscope. Let's have a look to see what we have here. Yeah. So that's the wrong circuit board. This is the little circuit board. The chip, I've got the glue off it. CM for Mark, Charlie Mike 6800G. Yes, that's the chip. On the flick side, we've got resistors. There's a transistor. One moment. Sorry about that, just the post arriving. Okay, yeah, so on the back of this we have, just get the focus on it properly. Some resistors, 0 ohm resistors we can see, transistor, some more 0 ohms. I think it's worth having just a quick check to see if the 0 ohm resistors are okay, yeah? Because if there's a kind of like fuse links, well, they probably are okay. That one looks okay. We'll check this. I think we got this one. Moment again. Too many interruptions today, guys. Too many interruptions. Are there any more? Yeah, there's a few more up here. Yeah, that's a good one. This one, yeah. Yeah. So we've got some more up here. Maybe. Unless I got these before, that one's okay. That's okay. So that's what's on there. They all look alright. There's a diode, which we can just check that as well if we get the meter into the diode mode. Okay. Glasses off again. So there's a diode here. Looks like a diode. Nothing the other way. There's probably a transistor or a FET here. So let's see if it reads anything. Doesn't read anything. Oh yeah, just like a diode there. Oh no, it does. Reads two semiconductor junctions. That's probably okay. A couple more diodes here. Let's have a quick look at these. Looks like it should be the cathode. Yeah. Yeah. So they look okay. So nothing catastrophic's happened on here, I think we can pretty say. Let's have a look at this chip and see if we can find the data sheet for this one. Okay guys, so we do have a data sheet for this one. That's quite handy. Here's the data sheet. So it is what I pretty much figured it must be. Power factor correction and pulse width modulator controller combo. It does the both, yeah. It tells you a few things about it here. Voltage in OK, guaranteed to turn on pulse width modulation at 2.5. Why instead of 1.5 I don't know. A little bit more information about it here. That one's interesting. This V in OK guaranteed to turn on the pulse width modulation. Okay, whatever that one means. Let's see if we find the pin out. Yeah. So this is the pin out for you, 16 pin. I don't see a V in OK as one of the pins here, which is quite interesting. Let's look at the pin description. Here we are. So this is all the various pins on the device. Yeah. pulse width modulation out is on 11, ground is 10. That's your pulse width modulation, that's your square wave output to the main power supply. This is square wave output to the PFC, and this is your positive supply. So 10, 11, 12, 13 are interesting pins. And look at the other pins. I don't see anything to do with this V in, what do they call it? Features. V in, okay, guaranteed to turn on pulse width modulation at 2.5. I'm going to say it's pin compatible with these. Okay. I had a look down through this description, and I can't see any particular mention of there being like an enable pin, effectively. Yeah. Looking at all the pins here, there doesn't seem to be an enable pin, and I'm wondering if somehow the this gets switched on by effectively switching on or off the power supply voltage to it. Here's a block diagram of it. I can see there's a 7.5 volt voltage reference in it. I think if we check, see if this has got power, yeah, and if we can see a VREF on pin 14, that gives us a good indication that it may well actually be working. It doesn't tell us exactly, but if we see power going in and no VREF, I think we can pretty much say this chip's dead, or there's a short from here to ground. If you look further down here, a lot of information on it. I've looked through the description again. I've had a quick look at this, and I couldn't see any mention of there being an enable pin. And further on, again, we will actually find like an example circuit for this, yeah, application circuit. So you can see VCC. This is your power supply, yeah, VCC. This initially comes through two high value resistors from, this is your output of your bridge rectifier, this is your bridge rectifier positive, yeah, and these will be high value resistors that feed the power to here, that start the chip up, yeah. Probably then there'll be a secondary winding on the switch mode transformer, this thing, yeah, which feeds the power back to the chip to keep it running. That's quite common. PFC out, we can see here, this is driving through two transistors. These are your switching FET or FETs. This is your PFC coil, yeah. This is your diode. This is your boost controller. I think we can also check if we compare the input voltage from the bridge rectifier to what's on the main capacitor. That'll tell us if the PFC is running. This should be higher than this considerably, yeah. I don't think it was. I think I was reading about 350. I'll check see if it is running. I don't think it is running, yeah. The other output on here is the pulse width modulation out, and this is your main power supply. This is slightly different from ours. You've got the coil, you've got one switching transistor here, yeah. Again, switch from this is your PWM out. Again, VCC, the power supply needs to be there. At first when I saw this, I thought, oh, that's strange. This kind of like turns the transistors on and shorts VCC to ground. But actually, in fact, it doesn't if you look at it. There's one PNP and one NPN. And if you think about it here, when this voltage goes up, the square wave goes up, yeah, the voltage on here will rise. So this transistor will turn on because the base is moving further away from the emitter. And this will turn off because the base is moving closer to the emitter, yeah, voltage wise. And the opposite, when this goes down, the base voltage drops, this turns off. The base voltage here goes lower than the emitter, this turns on. So these turn on and off in turn. You can't just short that out, yeah. I saw the same on here, by the way. Same little get up, and for me, I thought, what's that about? It's shorting out the power supply to the VCC. It isn't. Okay, so this is your main power supply section, yeah. And that's really what we have here. But I think the first thing we need to do is to check some things. So we need to figure out which pins on the little connector going to the main board, yeah, or the ones we're interested in. I think it was 10, 11, 12, 13. Let's just go back up to the pin description, yeah. It was way up here somewhere. Here we go. So we're interested in particular in 10 ground, 11 PWM out, 12 PFC out, and VCC. I'm very interested to see if this chip has got any power supply from VCC to ground. We know VCC can be up to about 20 volts. It tells us here, look, minimum 10, typically 15, up to 18, yeah. Minimum typical max operating voltage. So we expect VCC to have that sort of voltage on this, yeah? If not, the thing's got no supply, and we need to have a look to see why it's got no supply. If it's got supply and it's not working, then I think we can say it's faulty, yeah? Okay, so pins 10, 11, 12, 13 and 14. I'm interested to see if this reference voltage is actually here, yeah? So let's go back over to the desktop and let's have a look at those. Desktop camera, here we go, yeah. So this is our little board. So there's 8 pins, 9, this is 10, this is ground, yeah? And I'm expecting it to go somewhere to here. Well, it must go somewhere to here. That one. That's ground, yeah? So 11 is one of the outputs. Oh, it goes to the next pin. 12 is the other output. Goes to the pin. And 13, this is your supply. Oh yeah, it goes to the pin, they're all in order. So 10, 11, 12, 13 are the ones we were interested in. Does 14 go to any of these? 9, 10, 11, 12, 13, 14. This is VREF. No, it doesn't. Doesn't go anywhere off the board, yeah. Okay. So that one we could probably measure on the chip if we want to, but 13, 12, 11, 10 in order there. That's exactly what we want to be looking at, yeah. 9, 10, yeah. Okay, so we'll solder this back onto the power supply. We'll put the other board back on the power supply, and then we'll have a look to see if this actually gets any supply voltage or not. Okay, what I didn't just mention, by the way, is the fact there was a pin I checked before that was coming from the optimizer, one of them, to this board, yeah. So I've just had a look actually, and that pin actually goes to pin 6 on this chip, which is a pulse width modulation voltage feedback input. So that opto isolator will be controlling the pulse width modulator, yeah, it goes to pin 6. And that feedback is what sets the output voltages, that's what regulates it, yeah. So that's where the opto isolator goes to. The other opto isolator, I have a strong suspicion it's disappearing into some circuitry that basically turns the power to this chip, this board, on or off, yeah. So I did show you before, these are the two opto isolators, and one of them, if I just find the end that doesn't go to ground, that end goes to ground, so the other end of it goes onto here, yeah, on one of the pins. Oh no, it was this one, sorry. Yeah, goes to here, yeah, and that goes to pin 6 on the chip, yeah, goes to pin 6 on here, sorry, on here, yeah, and that is effectively the feedback. So the other opto isolator, my guess is the other opto isolator, this one, is involved with turning the power supply on to this board. So what we're going to do is now, I've put everything back together, I've put the transistors back in. I'm going to check now to see if on pin 13, which is this one, there's any drive, yeah? 13, 12, 11, 10. This was pin 10, the fourth one in. And by the way, that goes to ground. You said it was ground, and if we look, that's the ground end of the big capacitor, yeah? That's the ground end of here. So what I'm interested in is 13. Does this thing actually have any VCC? Does it get any power? Yeah. So let's connect it up and let's have a look at that. Okay, so it's ready to test. I've soldered basically a power socket onto this because obviously it's all out to the case at the moment. So this is just your power. It doesn't matter which is live and neutral because my plugs in the EU. They're not polarized anyway, so there's no way of knowing if it's actually live or neutral. But this is your 240 volts AC, yeah. And what we're really interested in, if we make the meter a little bit bigger as well, so you can see what we're interested in. First of all, this is your main power supply, yeah. It's not plugged in at the moment. This is your main power supply. So this is where we're going to get the sort of 300 volts or so. I'm interested to see what that was actually, to see if the PFC is running or not, yeah. The other point we're interested in is this one here, which is the VCC to this controller, yeah. So let's have a look, let's see what we've got. Okay, just untangle my wires. Okay, so first of all, we'll put the power on. It's connected via the light bulb again. You can't see the light bulb, but it is connected via the light bulb limiter for safety. Yeah. So first of all, what happens now? So the light bulb flicked and went off. Yeah. We've now got power on this, so we can go here across the main capacitor. 320 volts. Yeah. The other point we're interested in is the VCC to this chip here. Yeah. And this is to negative 0.6. Right, okay. I've switched it off. That's told us what we need to know. We've got no power supply drive. Let's just discharge this main capacitor to make this thing safe again, yeah. So, pair of pliers. 3.3k resistor, power is off. Power is off on 2 switches now. And we're just going to discharge the main capacitor, yeah, to make this thing safe. Okay, that should be discharged now. Negative, yeah, about a volt or so. Okay, so we know it's safe. We know we have no power supply getting to the PFC, yeah. So we also know one of the opto isolators, this one, kind of disappears into some transistors around here, and I'm suspecting that is what's switching the power on to this, yeah. If we go into resistance mode, yeah, and we have a look, okay, just make sure this is fully discharged. Right, I'm on resistance mode. I'm sure it will be. It was before. 1.6. I'll try and get all the charge out of this, because sometimes it's actually a small voltage like this actually screws up the resistance readings, yeah. That's low enough there, okay. So we know this pin is the VCC supply, yeah, to the controller. It comes from somewhere, it comes from down here. Goes to a resistor here. 20 ohms, yeah. So it looks like it goes through a 20 ohm resistor and to a capacitor. I'll bet the other end of this capacitor goes to ground. Yeah, it does. So that's your supply there, yeah. And does that come from one of these transistors down here? Yeah, it does. That's probably the collector, or again it might be a FET. So that comes from this transistor. Will the end of that transistor go to ground? No. But it comes through a transistor here, and this transistor, I'm guessing this is probably the base. I'm just guessing. Goes over here. Does that disappear? I'm trying to find some connection from here back to the opto isolators and say, but I'm pretty sure this transistor probably turns on or removes the power supply to this, yeah. And the other opto isolator, there's another transistor here, yeah. So what I'm going to have to do now is I'm going to have to sit down and just work out this circuit. It's time consuming, but I'm going to effectively try and draw the circuit from this pin to figure out if I can see how almost certainly this opto isolator enables this, yeah, to turn it on. And I think that's probably where the problem is, that it's not getting the turn on signal. It might be that the other side of this isn't being driven, and maybe that's why. So effectively this isn't sending a turn on signal. But the only way to figure that out now is going to be to reverse engineer this bit of wiring around here, yeah. It's not a lot of it, and see. So I'll do that off camera, and I'll come back when I've figured out how it all connects. Oops, how it all connects up together. Okay, see you soon. Okay guys, I had a look around, yeah, and I kind of figured out how this connects up. So this is, let me just take it off here, this is pin 13 of the chip, yeah, that drives the main power supply and the PFC, yeah, and we've got no voltage on it, as we know. So I traced it back. There's a first thing I spotted was a 7815. This device, LM78L15, which is a 15 volt regulator. And I looked up the data sheet and we can see pins 1, 2 and 3 are in, ground and out as one, yeah. And I had a look at how it was wired, yeah. And it's wired up like this. So this is pin 3, this is pin 1, this is pin 2, yeah. 2 goes to hot ground, out as expected goes to our chip, yeah. So I looked from the in and I found this goes to a transistor Q11. The voltage regulator, by the way, I'll just show you where it is on the power supply, yeah. So this is our little control board where we need power, and this thing here with 3 legs you can see there, that's actually the voltage regulator. Can we see it? Yeah, a bit of light, and yeah, it's there. Okay, that's the 78L15. That gets its power via a transistor, which had a code on it. It's a surface mount one, yeah, and it's actually let me just find it. It's here, yeah. And this transistor basically has a code on it, W2F and then 04. So I looked up WTF04 data sheet and I didn't find anything. So I looked up just W2F SMD code, because really this is an SMD code, it's not a part number as such, yeah. And once I did that, I found that I could find out what it was. PMBT2907A. Just 1 second. Thought you ought to point the other camera in my direction, yeah. Hi guys. So I looked up this SMD code and I found a pin out for this one. It's a PNP transistor, yeah. I probed around it, I could see diode junctions, but I couldn't quite figure out if it was an NPN or PNP, because I was reading diodes everywhere. So I looked up the data sheet and I found this is the data sheet, and from that I worked out collector base emitter, yeah, and collector goes down to the input of this. So it's obvious this takes its input voltage via this transistor, yeah. I then had a look around the resistors around here and I found that the emitter has a 1k resistor going down to the base, yeah. From there there's a 4k7 resistor through this photo transistor. This is your opto isolator, yeah, to ground. So I think it's fairly obvious we did a bit of thing on bipolar transistors, but for this to switch on, the base has to be below the emitter voltage, 0.6 below, yeah. And that's what this does. When this transistor switches on, in other words the LED is on, shining light on it, it connects this to ground, yeah. So these two resistors form a voltage divider and they reduce the voltage at the base. If you take this 4k resistor end to ground, the voltage here will drop. If this transistor is off, the voltage here will be the same as the voltage here because there's no current path, yeah. So that's how it works. That's obviously how it works. I then traced from here and found it goes round the board to an electrolytic capacitor, a 35 volt one, through a 10k resistor, and this is the chip that powers the 5 volt standby, yeah, it goes to there. So that's how it was wired up. So let's have a look at the voltages on this now. This transistor needs to be turned on for this to work, yeah. So the LED needs to be on, this will be on, this will be on, and then this gets power, yeah, and powers this chip up, and then it starts the main power supply. That's how it works, yeah. So let's have a look, see what we've got on ours. I'll just connect everything up. So 1 moment, I'll do it. Okay, we're on. So we connected via the light bulb. I'll just switch her on, yeah. Right, it's on now. So we can check. We should have main voltage here about 320 volts, yeah. If the PFC was running, that'd be more like 375. So from ground here, this is the output of the voltage regulator, yeah. There's nothing there. We go to the input and there's practically nothing there, yeah. That input comes via this transistor, yeah. Where are we? Via this transistor, yeah. The other end of the transistor goes to R101, yeah, and R101 is down this side of the board. So from ground again to R101 is here, yeah. And this has 14.6 volts on. The other end goes to that TNY chip, and that has 6 volts on, yeah. So this is powering the TNY chip. The 14 volts is coming from somewhere else, yeah, onto this voltage rail. Now, this transistor is apparently switched off. We've got 14 volts here, but nothing here. So let's have a look on pin 4 of the opto-isolator. If this is 14, this opto-isolator is switched off, yeah? If it's 0, it's switched on, and this should be switched on. So let's have a look at it. The opto-isolator is actually here, yeah? This is the opto-isolator. So again, from the minus of the big capacitor to the opto-isolator. That pin is probably ground. What's on the other pin? 14. So there's 14.6 on the opto-isolator, yeah? Here, 14.6, the same as here. So this transistor is switched off. Yeah, we know because this doesn't power up. The transistor should be okay, it's just switched off. What's on the diode, yeah? Let's go to the other side of the diode. So this is on the low voltage side now. This is the diode, yeah? Let's look what's reading on the diode. About a volt, yeah? About a volt. 1.1. So on the other one, this is the other opto-isolator. That's nothing. So it looks like this opto-isolator is probably turned on, and yet the power supply isn't working, yeah? There's no output voltage on it. So I'm suspecting if we go across, this is the transistor of the opto-isolator. Yeah, it's switched off. Yeah. So this is looking to me like either 1.1 volts isn't enough to turn the opto-isolator on, which it probably would be for an LED, or the opto-isolator is faulty. Yeah, it doesn't work. So okay, I've switched everything off. Let's get all the high voltage out of this thing. Yeah, let's make it safe again. Everything powers off. Just discharge the big capacitor. Okay, that should be discharged then. Yeah, it's about 2 volts, I think. So this opto-isolator looks like it's got power, so it should be lit up, so this transistor should be on, and it isn't. That's looking suspicious, like it's faulty to me. Let's see if we can determine that. So the 2 opto-isolators on the board, yeah, there's 2. I want to see if they're the same. And if they're the same, I want to measure the resistance, if you like, the voltage drop across the LED. So let me have a quick look to see if they are actually the same. It's a bit awkward to see down here. I'll have to use the jeweler's loop, yeah. Yeah, they are the same. Oops, I've lost the camera, one moment. Yes, they are the same. They're actually marked Cosmo 1010. I've actually, previously when I was working all this out, I actually looked up the data sheet, so that's how I know the correct pin out of this, yeah, the right way it is. So I looked up the Cosmo 1010 and it brought me to C1010 opto-isolator, and that's how I figured that one out. So all this is just done from data sheets and just figuring out what wire goes where, yeah? There's nothing overly complex about that. It took me maybe 30 minutes, so that's why I did it off camera. But if you guys are interested in this sort of thing and how I'm actually doing it, let me know, and I will do, the next time I come across this, I'll do it on camera. But it could make the video pretty long, yeah, because I have to, you know, poke around and try and just work it all out. It does help if you've got an idea in your head how it was. Once I found that voltage regulator, I knew I was on the right track. This having 14 volts, by the way, this regulator effectively wouldn't regulate. It would only regulate if this voltage went up to about 17 or 18. So I suspect this is in a way not being used as a regulator. This chip can handle up from 12 to 18 volts, I think, was its working voltage. I think this is more being used as a limiter to stop the voltage going above 15. It doesn't matter if it's below, as long as it's above 12, yeah? Okay, so let's have a look at these 2 opto-isolators. They're the same. So you would expect, I mean, depending on what's in the circuit, yeah, you would expect the LEDs on the 2 of them to basically read identical, yeah. So here we go. One moment. Yep, phone call. It's been a busy day today. It's this Euro 2020 final. A lot of people have these satellite boxes being sport here, which they're not supposed to have because it's supposed to be in Arabic countries, that's just across the water from here. We get a good signal. So they want to put the final on. They could have had the whole tournament, but it was like 90 quid or something. They didn't want to pay extra. And now, of course, England in the final, they all want it, don't they? And they thought, well, can we have just a final for 20? No, it's 90 quid. It was 90 quid before, and it's still 90 quid. Take your choice. I mean, they had the chance previously, yeah, but they didn't want it. Okay. I mean, some of them have BBC and ITV. They got big enough satellite dishes, or rather, you got the dish on the right satellite, not the Sky satellite, by the way. We need 4 meters for that. Anyway, I'm waffling. Sorry. Back to this, yeah. So these are your 2 opto isolators, yeah. Always like make sure everything's unplugged. I was just looking one side, make sure the power is all off. So we're on diode mode, yeah. This is one of them, and that reads nothing that way. Pin 1 to 2. What's this one read? 0.6. This one reads 0.5 that way, and this reads 0.99, 0.1. Well, you'd think it'd be enough to turn the transistor on. Sorry, turn the LED on. I honestly think I've got a faulty opto isolator, because I've got 2 the same. It's going to be easy to take them off the board, yeah, and check them as they are, yeah. In fact, I'll switch the 2 over. Man, though, probably if I do that, the standby will switch off because the feedback isn't working. Okay, let me just get this desolder warmed up. Let's try it. Okay, so here are the 2 opto isolators. I put a little scratch mark on this one. Yeah, this one. This is the one that I think is probably faulty. Let's have a look. So pin 1 and 2 are over this end, yeah. It's reading 102. And that doesn't read. That's kind of what I thought an opto isolator would read. How's this one reading? 102. And then the other end obviously doesn't read, it's a photo transistor, yeah. So they sort of look the same. Yeah, they sort of look the same. We can test these. Just give us a minute. Let's see what we get. Okay, so here's our opto isolators, yeah. And I've just connected. This is multimeter on diode test mode, yeah. And I've got these little crocodile clips, so the greens to the black and the yellow ones to the red somewhere across my desk, yeah. Fine, you can view there, yeah. So I've got this connected to the transistor. I'm not using these resistors as resistors. I've just literally used my stiff bits of wire, yeah. And what we can do is, with this multimeter on diode mode, if we connect across this diode, the LED, we should see the voltage reading on this, which is, I think was 1.06, yeah, and we should see it switch on. Yeah, you see that? So we've got 1.03, and you can see the readings changed on the other one, but the transistor is like sort of partly turned on. Let's have a look at the other one. I mean, I expect if it was turned on, I'd go to 0, yeah. Let's have a look at this one. Okay, let's try it on this one. So this is the other one, yeah. Same thing happens, yeah. 1.03, and that gives to about 2.5 volts. The one which is faulty, I put a little scratch mark on it, yeah. Let me see which one it was. It's the bottom one, yeah. This is the one that's appeared to be faulty. Okay, so they're sort of working, but I'm not sure they're turning on properly. Let's go back to this one, yeah. This is the one that I think was faulty. So we go in here. What I'm now going to do, I'm going to attach from my bench power supply, yeah. So if I just figure out where I've put the leads, because we're all over the desk now. Where are we? Well, wires everywhere. I should tidy up while I'm doing this. Okay. This is the positive for my bench power supply, yeah, and the negative around here somewhere for my bench power supply. Where's it gone? Got it, okay. This is the plus and minus from the bench power supply, yeah, and you can see if I just connect it to my test meter, yeah. I've got about 6 volts. Okay. So negative, I'm going to connect to the negative, the cathode of the LED in the optical isolator. I've now got a 390k resistor. I figured that would give 6 volts, what was it, 20 milliamp, no, 5 milliamp, something like that. So I'm going to put this power on here now. That's what happens to here. Now the transistor's turned on. Can you see that? Voltage has gone down to 0.07. So that appears to be working. I'm sure the other one will do the same thing. Okay, put that one in there. Let's again put some voltage on this one. Do we have a connection? Connect the meter to the right one, yeah. Put all the wires in the right place, yeah. That's that one. Let's see if this one turns on. Yeah. Yeah, you can see it's turning on. I've got a bad connection on the resistor into the hole. Yeah, 0.07. So these definitely need more voltage to switch on properly. Let's connect the power supply to the resistor and let's actually measure the voltage that's now driving it, yeah, on here to make it come on properly, yeah. It's 1.18. Just that little bit more voltage to turn them on. And when it's in the circuit on the power supply, it's not happening, it's not turning on. Yeah. So where's that LED and that optical isolator come from? Well, it's over here, yeah. And I'm sure it must come from this controller over here somewhere. So let's have a look. One end will be ground. And find the ground. I'm pretty sure one end will be ground. Well, it might go via resistor to ground, yeah. Right, okay, it doesn't seem to go to ground. Let's have a look on here. Right, one end goes directly to the controller board here. Yeah. One end is directly to controller board. What's the resistance of the other one to ground? So this one to ground. It's like I've got no circuit path to ground. Yeah. Oh, maybe it goes the other way. Maybe it goes to 5 volts. Yeah, it's quite possible. Which pin is going to the controller? Pin 2. Yeah, pin 2 is here. Yeah, this is like effectively the ground end. So the controller must ground this end of the LED, yeah. And the other end must have 5 volts on it, or via resistor. Oh, it's right, it had 1 point something volts, so we know what was on it. So this end, I'm guessing it goes to 5 volts. Now let's check 5 volts standby. That's a good place to go. I'm guessing. I'm assuming. I'm not guessing. I'm making the assumption the other end of the LED must go to 5 volts standby. Because that's the only power on this side of the board. Yeah, and probably via resistor. Yeah, 0.47k, 470 ohm. That means exactly what you'd expect. Remember, I was using a 390 ohm resistor off my power supply at 6 volts, and it was switching it on. That's using a 470 ohm, so that's fine. And then the other end of this is obviously going to this controller here. Yeah, and we can say this controller isn't switching this LED on. Now on here all we had was some resistors which we checked them all really, and they all looked okay, and we had a couple of diodes which looked okay. So the only thing left on this board here is the controller chip. Yeah, controller chip. But actually there's another reason why this opto isolator wouldn't be turning the transistor on, and that's because this LED is controlled by the monitor chip over here. So this effectively tells the power supply to switch on by effectively illuminating this LED in the opto isolator and turning the transistor on. Yeah, turning it all on. But it won't do that unless it has 0 volts on the green wire in the ATX, yeah, and it doesn't have, because I haven't got it plugged into my analyzer. So let's connect this to the analyzer and then let's see what this does. Yeah. So we'll put the power analyzer on here. Okay. So that's on there. Okay. And let's see what happens now. I mean, it wasn't working previously, so you'd expect it not to be working, basically. We connected via the light bulb, the limiter. Let's see what it actually does now. Well, the light bulb's come on. It tried to power up this time. That's interesting. It tried to power up, and I don't really. The only thing I've been doing, I was just soldering around the opto isolators when I was just trying to figure out, why it wasn't working. And this time, it actually gave a bleep and tried to power on, but the light bulb's coming on. But we know this as PFC, so I'm wondering now if we just. I'll show you what's happening. Bulb on, yeah, 150 watt with the PFC. So the only other thing I think we can actually do with this now is basically switch it on, yeah, go straight to the power, and then either this will go bang or it'll boot up. Nothing, nothing much else I can say really, apart from, are we ready to see what happens? It booted up. I went, cringe. It's running now, but not running properly. It's saying a lot of voltages are low. But this time it actually did boot up, just not running, the correct voltages. Let's try that, and then I think it's shut down. Let's try that again and see if we can see on the analyzer what it's saying. Now it doesn't power up. Now it doesn't power up. This is proving to be quite a tricky one, to be quite honest. I'm assuming we've got power on the main capacitor. Let's have a look. No, it's discharged the capacitor now because obviously it was drawing power. That makes sense. If the power supply is running, then the big capacitor will discharge when you switch off, yeah? And I'm guessing that we've now got, if I can get it to fire back up again, we've now got the boost working, yeah, the PFC. So you'd assume this would go up to about 375 or something like that when it's running. Let's have a look again. No, now something's now something isn't working. Switch it on again. Counter the connections with one hand. Okay. I'm getting no power into the main capacitors anymore. This is still switched to live. Set it back to the limit, yeah, but I'm assuming this is not going to light up now because nothing's coming through into here. Okay, let's try it. No, the light bulb doesn't light up. Have I blown the fuse? There's a fuse gone. There's nothing to discharge here. Just 3 volts, yeah. Yeah, almost no voltage. Let's have a look. Let's have a look to see what we have. Turn it over. Fuse is going to be resistance mode. There's a fuse somewhere in this. Oh, is this here? I'm guessing that this thing here is a fuse, yeah? It looks like it should be a fuse with like a little plastic sleeving on it, yeah? So let's have a look. It's on the input. No, fuse is okay. Then it comes through whatever here. Low value resistance. That the thermistor maybe. Oh, that's interesting. Why have we got no power on this now? What's happened? What's the difference? Live or neutral in. Bridge rectifier. I think we have a failure of the test equipment, yeah? Like, I've obviously got power there. Is it blowing the fuse in the plug? Is it blowing the fuse in the plug? No. So why do I have no power anymore? This is a good question, isn't it? Why do I have no power anymore? Just let me get this paperwork and stuff out of the way. This analyzer still plugged on there, so it should power up. Light bulb still in circuit, yeah. Limit, yeah. I don't know, guys. It's a bit of a mystery, this one. Voltage. Huh? Main capacitors. I've turned these all upside down. Now I can't bloody see where they are. No voltage. That's very strange. Right, let's have a figure out what's going on. AC, yeah. So we go to the AC coming in. 220 volts coming in. Bridge rectifier. Well, this goes to the mains capacitor. Something's gone pop here, guys. Something's gone. Can't be the bridge rectifier, can it? I mean, I didn't hear anything go pop. You know, I didn't actually hear a bang, if you know what I mean. Just to isolate that. Yeah, diode mode. I don't believe for a minute that these have gone. Wouldn't make any sense. There's something wrong with the connection from here to here. But there isn't. How much sense does that make, guys? How much sense does that make? 0 at the moment. Very strange. Let's see if we can figure out what's going on with this one. Okay, guys, I've made some sense out of it at last. Basically, the fuse is blown. This is the plug that's coming from my variac up on the side of the bench here. So this feeds the power eventually down into this, yeah. And what's happened is the fuse here has blown. Yeah, 5 amp fuse is blown. I didn't hear anything go pop, which is quite surprising, but 5 amp fuse is blown. So that's why I've got no power coming into here, even though I have the power coming in to the bridge rectifier. So that's one side AC, this is the other side AC, yeah. And what's happened is, if we look now across this bridge rectifier, yeah, it's completely short. So there's a dead short on this now, so something's gone pop. If I look across the main capacitor, there isn't a short. So I see a short on the bridge rectifier, but I don't see a short on the main capacitor, yeah? So what's in between them two? The PFC. So from... this is the negative of the bridge rectifier. This is the negative of the big capacitor. Yeah, that's there. But from the positive of the bridge rectifier, it's going through a diode. That diode, as you can see, is in the PFC, yeah? And the PFC down here, if we look at the main switching transistors, there's one here and one here, and this one reads short circuit. Yeah, that's dead short. So for some reason the controller decided to switch this on. Obviously it did switch the power supply on. It run for a few seconds. I was getting low voltage. Now I know there's no short circuit on any of the outputs here, yeah? This is the output from the power supply. I checked this earlier, probably not on the video, but I had checked this, so I know that I don't or didn't have any short circuit on any of the outputs. Well, let's see what we have now. I just need to go onto diode, onto a normal resistance measure. That's like 50 ohms on the 3.3. That's okay. That's okay on the 5, and the 12 is also okay. Yeah, they're okay. Let's find the other 12 volt rails. Just check these as well. Yeah, so there's no shorts there. There's no shorts there. Yeah, so I don't have any short circuits on any of the outputs from this, but the PFC's gone bang basically. So let's unsolder this. Yeah, let's desolder this heatsink with the devices on, and let's have a look to see what's actually happened here. Okay guys, so I've desoldered the PFC. So these two FETs here, if you look on the board, they're actually in parallel. Yeah, so you can see that these two are in parallel. Yeah, both the drain and the source, yeah, are in parallel. The gate's just got their own little drive resistor, and these have gone short, I would think. So let's have a look at what we've got. Yeah, just on resistance mode. So that's basically short circuit, yeah. But this one isn't. And then this is the other one's the diode, which I know is intact because I was reading the diode junction between the bridge rectifier and the capacitor positive, yeah. So I know this is okay. There. Looks like one of these FETs is okay as well. This is interesting because like nothing catastrophic's happened. Otherwise, first of all, there would have been a bang, yeah. And secondly, both of these would have blown. I mean, let's have a look what this one's doing. Yeah, that one's actually okay. Okay, I think what appears to be going on with this, but this is a bit of supposition. This controller obviously can switch this on because it did run, yeah. So obviously the opto isolators are okay. I mean, I'd soldered around these. Whether there was a bad joint before, I don't know. I doubt it. It seems like this is kind of detecting some sort of error and wasn't powering it up effectively, or it power up and shut back straight back down again. And then for some reason it decided to power up. And once it did power up, one of these just gave up the ghost by the looks of it. It took out the 5 amp fuse on the variac, which is why I couldn't figure out, hang on, there's a short, but I haven't got a short. I've got a circuit here to capacitors, but there's nothing getting through, and that's what it was. I'm wondering if one of these was perhaps what was causing the problem all along. So effectively, like the controller here would power this up and then sort of power it back down again. I think what I'll do with this one, I need to order the FETs. So I've got to order FETs anyway, without a doubt. I need to do that. I might as well order one of the controller chips as well. I can't just remember the part number. It was earlier on this video, but they were cheap. And while I'm at it, let's order one of these supervisor chips as well, because they were also very cheap. And that will give us, I'll order a few, and that will give us, enough to get this thing running again. Obviously, I won't be switching the light bulb limiter out, because obviously as I put that out, that's when it went. And we'll have a look. So this is going on to another video. I can't fix it today, need parts. Hope you found this an interesting one. It's certainly quite an in-depth repair, this one, and I'm sure there's plenty here for us to learn. So I'll see you soon on another video, and I'll be back when I have the parts on this one. See you soon now. Ciao guys.